Hello everyone, welcome to Raj Malhotra IAS, and today we are going to talk about quantum technology and its potentials for India. Friends, from my experience of multiple prelims and multiple mains, I am quite sure about one thing, that whenever the terms such as biotechnology, whenever the terms such as nanotechnology, and whenever the terms such as quantum technology are in news, UPSC becomes desperate to ask a question either in the prelims or in the mains related to these topics. So these topics are very important, and you know that quantum technology has been in quite some news from last year after the launch of national mission, after the launch of national mission on quantum technology application. So that becomes an imperative for us to discuss everything in detail related to quantum technology. In this presentation, I'm going to talk to you about what is quantum technology, and I'm also going to talk about what are the applications of quantum technology. And next time, National Mission on Quantum Technology and Application will be in news. We'll be discussing this national mission in quite some length. So hold your seats and learn the concept that is quantum technology and its potential for India. Now, what is quantum technology? Whenever this kind of question comes up, you should define quantum technology in a very layman language. I know many of you may be from physics, but you do not require the physics knowledge to present your answer there in the paper. All right, so what you are going to do, you are going to write a very simplistic definition of what is quantum technology. All right, or you can, like for example, you can say that quantum technology is the emerging field of physics and engineering that incorporates the principles of quantum physics. That incorporates the principles of quantum physics. Now, the principles of quantum physics are those physics principles which are different from conventional physics. Conventional physics is basically the physics that you study up to your class 10th, 11th, as well as 12th. All right, so conventional physics is the classical physics where the size of the particles whose interaction you are studying is more than, in fact, much more than 10 to the minus 10 meter, which is typically the atomic size. All right, so your size of your particles in classical physics, the size of your particles in classical physics, they are certainly much more than the atomic and nuclear physics. But once you enter into the atomic or nuclear, once you enter into the atomic or nuclear physics realm, at that time, what happened? At that time, these principles are no longer applicable. And when these principles are no longer applicable, you need new physics, and this new physics is known as quantum physics. This new physics or quantum physics, it was discovered, or you can say it began to be developed in the beginning of the 20th century. So the entire 20th century, quantum physics has developed over the period of time. And today these principles find a lot of application in technology as well as engineering. And this becomes the basis of what is known as quantum technology. And this is the precise definition that I expect you to write in your mains examination if a question comes on quantum technology. All right. So this is the definition that you can also collaborate or incorporate in your answers. Let us go ahead, ladies and gentlemen. Now we are going to talk about some of the applications of quantum technology. And these applications are what we have a potential for application in our own countries, Now, the thing is this, our country has recognized the potential of application of quantum technology. And for this, we have already launched the national mission. It is a national mission on quantum technology and application. In one of the previous weekly current affairs class, we have already covered this NMQTA. And if given a chance this time, or if it comes in news again, we are going to discover this national mission once again in our weekly current affairs class on Saturdays from 12 noon onwards. All right. So this national mission on quantum technology application, it focuses in our country to incorporate this quantum technology in the field of quantum computers, in the field of secure communications through quantum cryptography, in the field of disaster management, in the field of pharmaceutical research, in the field of industrial revolution, and in space research, as well as other scientific research taking place in our country. So what are these applications we are going to discuss, and they will become the potential ground of a mains question. Like, for example, in one of the previous year mains examination, UPSC asked that what are the applications of, what are the aims and ambitions of the biotechnology or nanotechnology mission. So similarly, this time they can ask you what are the aims and ambitions of the quantum technology mission. So let us go ahead now. Now we are going to first talk about quantum computers, which is the first application of quantum technology. Now, many of you do not know the basics of computer, and it might be a bit tricky for you, but I will try my best that you get to learn about quantum computers in the simplest of manner. So if we talk about quantum computers को समझने के लिए first we'll have to deal with simple or classical computers. So our classical computers, they are making use of binary mathematics. All right, so classical computers, they make use of what is known as binary calculations. That is, there are 2 bits. The information in classical computers is given in the form of bits. And there are 2 bits, 0 and 1. That is, every information will be coded in either a 0 or 1. This is the principle of classical computers. All right, like for example, if I have to present a 2-bit system, all right, the 2-bit system, this 2-bit system can take place as 00, 01, 10, 11. That is, my 2-bit system is giving me 4 possible combinations to encode the information, right? Now, the thing is this, in quantum computers, instead of using these classical bits, we are using what is known as quantum bits. So let me introduce to you what is quantum bits. So in quantum computers, you use what is known as qubit instead of bits. Qubit is nothing but it is a short form for quantum bit. Quantum bit. Now, in your science and technology class, you must have heard about what is the principle of superposition. I'm going to give a very passing reference to the concept of superposition. Please try to understand. In quantum realm, a particular information will be partially in the form of 0 and partially in the form of 1. That is, unlike classical computer where if the information is 0, that means the information is fixed, that it is 0, or the information can at max take the value 1, but no value in between. Right, so there are only 2 discrete possibility out of 1 bit. Out of 1 bit, either the value will be 0 or 1. But in case of qubit, the possibility will be that a state is represented as alpha 0 plus beta 1. That is, it is superposition of 0 as well as 1, and alpha can take any value between 0 to 1, and beta will be then equal to 1 minus alpha. Are you seeing this beauty? That alpha can take infinite values between 0 and 1. Therefore, beta can also take infinite value corresponding to 1 minus alpha. So what classical computers were doing, the classical computers were out of 1 bit, the classical computer was giving only 2 possibility, 0 or 1. But out of 1 qubit, this quantum computer is giving you infinite possibility. There are infinite ways to encode the information in a qubit. Whereas in a classical computer, there are only 2 ways to encode the information. Now you yourself think the computation that will be done by a classical computer will only be dealing with 2 of the possibilities, whereas a quantum computer will deal with infinite possibilities. So the information that can be solved the information that can be stored in a quantum computer will be much, much, and much more than what there will be in the classical computers. And once these quantum computers are developed, it is going to change the face of the mankind once and forever. So this is the first application that is known as quantum computers. All right. So like, for example, if you can see these images on your screen, you can see that there are two possibilities of a bit 0 and 1, whereas the qubit is giving you a complete overlap of all the different possibilities between 0 and 1. So appreciate this. So here only two pieces of information, and here there are almost infinite piece of information. So which is going to store more information? Qubit. Which is going to give a greater processing speed? Qubit. And therefore, it is potentially said that if the quantum computers get developed, the face of the mankind will change once and forever. All right, let us go ahead now. Now, another important application of quantum technology is what is known as quantum cryptography. All right, quantum cryptography. To understand quantum cryptography, I must tell you what cryptography is. Suppose, let me tell you this thing, that there are two friends. This is Alice and this is Bob. All right, Alice and Bob. Alice wrote to Bob love. All right, and then she sent this letter love to Bob, and in between, Alice's mom Eve was there, which do not want Alice to love Bob. So Miss Eve, she intercepts this particular communication, and she reads the message of love sent by Alice to Bob. Now, what does Eve do? Eve shut Alice in a room to prevent Alice expressing her love for Bob. Now, what happened? Bob is a smart physicist. So what does Bob say? Bob say to Alice that do not send your message directly open. Instead, what you should do, Alice, my love, that you encode the message in a cryptographic manner. So what does Bob say to Alice? Bob says to Alice that what you have to convey to me, you take that letter and add one more letter to it and change the word. So for example, Alice, if you are writing love, then instead of L, put L plus 1. So it becomes LM. So it will become M. Instead of O, put 1. That is, it will become P. Instead of V, put one more, it will become W. And instead of E, put 1, it will become F. So now Alice is going to send the letter to Bob, that is MPWF. Bob will receive this letter, and he knows that from every letter, he has to minus one particular alphabet, and he will get what Alice wanted to convey to him. Now, in between, if Miss Eve drops in and checks the letter, she will realize that she is sending a message MPWF, which seriously does not make any sense. So now the information or the expression of love by Alice to Bob is secured through a communication. This is known as cryptography. But my dear friends, this is classical cryptography, and it is very, very easy to crack compared to quantum cryptography. In quantum cryptography, we make use of a quantum property that is known as entanglement. All right, that is known as entanglement. All right, entanglement kya hota hai? The quantum particles. Here, try to understand the quantum particles such as photons. Photons, they are produced in terms of pair. So if a photon has upward spin, the another photon that will be produced simultaneously will have the downward spin. All right. Now, suppose there's a very important principle in quantum physics, which again may sound a bit technical, but I'll try my best to explain you in the simplest of manner. So this is known as decomposition, quantum decomposition. So what does it mean? That if I read, all right, suppose I somewhere examine this photon to be up, the simultaneously the other photon will become down. All right, this is known as decomposition. You make a measurement of one state of the entanglement pair, the other pair automatically can be known because there is a paired production in quantum physics. All right. So now in quantum cryptography, we make use of this particular, what you can say, uh, technology for secured communication. So what is happening now? Alice. Alice is writing a message, and by a paired production, she encodes this message using a quantum photon such that the message is encrypted. All right, it is encrypted and it goes to Bob. Now, tells Bob that her quantum photon state was upspin. He will make use of downspin to decode the message and read the message. But my dear friends, in between Miss Eve, she does not know what is the state of photon of Alice, and she does not know what is the state of photon of Mr. Bob. So she cannot read the encrypted message at all. And quantum cryptography, secures the message in a much difficult manner such that it cannot be intercepted and by any Tom, Dick, and Harry. My dear friends, the fact is that China has made a significant progress in the field of quantum cryptography, and China has secured its communication to a significant level. If you remember the World War II, in World War II, Germany was winning the war because Germany had an encrypting machine that is known as Enigma machine. This Enigma machine was cracked by Alan Turing, was cracked by the mathematician Alan Turing. And because the Germans' Enigma machine got hacked, Alan Turing made the World War II to be won by the powers such as USA, UK, France, rather than Germany. And this is the reason, my dear friends, that cryptography is very important to secure your information. In fact, cryptography is necessary even to secure your privacy. And if you are a user of WhatsApp, in WhatsApp, it is written explicitly that the messages conveyed through this tool is secured through, is one-to-one secured through cryptography, right? So secure communications are important for national security. They are important for privacy. And National Mission on Quantum Technology and Application is focusing upon this dimension as well. Now, all rest are the applications of quantum computers. So quantum computers can be made to be used in predicting the tsunamis, drought, earthquakes, and floods. That is, quantum computers can make a very significant help in prediction of disasters and prevention of the hazards to be converted into disasters. Apart from this, you can also model the climate change very well if you make use of quantum computers, because quantum computers, they are making use of, because the quantum computers, they can store huge amount of information and they can go for very, very swift and quick, you can say, processing even of a very significant amount of information. So climate change models can be very much modeled by quantum computers. All right. Then apart from this, if you look into application of quantum computers, the quantum computers can help in modeling of the medicines and can significantly contribute in the growth of pharmaceutical industry in the country. Quantum computers can reduce the time frame by which a drug is discovered. All right, it can be reduced significantly by, like for example, the time which is taken by a new drug to develop, which is right now almost 10 years, because the classical computers are very slow. But if we make use of quantum computers and the models, the machines can be converted to be developed in few days rather than 10 years time. So pharmaceutical industry has a significant application of quantum technology as well. Another is augmenting industrial revolution 4.0. You know that today everything is getting controlled by internet. This is known as Internet of Things. It is making use of artificial intelligence as well as machine learning. And that is the reason, my dear friends, that if we have swift quantum computers, if we have quantum computers that can process huge amount of information quickly, that can process that can store and process a significant amount of information, the Internet of Things as well as the machine learning and artificial intelligence will become a very household names in future. Robotics, because robotics deals with a significant amount of information, you will be requiring the high speed quantum computers and high information storage quantum computers for robotics to become the next household items. All right, so quantum technology even has application in Industrial Revolution 4.0 that comprises of Internet of Things, machine learning, artificial intelligence, and robotics. Apart from this, quantum computers has a significant implement in researching the space phenomena such as gravity, such as the black hole. All right, and similarly, in Indian Space Research Organization, ISRO is developing many quantum computers or is working on quantum computer application in decoding the mysteries of space. All right, so quantum computers can be used in black hole and gravity research. It can also be used in biotechnology in sequencing the DNA and genome of human being. And we are also developing quantum technological applications even in the field of genome sequencing. Agriculture and medicine is the next important field. And lastly, aerospace engineering, not to mention, has a significant application of quantum computers as well. Coming to next, for this, the government of India launched the National Mission on Quantum Technology and Application. And this was launched in the budget 2020, where 8,000 crore rupees was set over for next 5 years for the development of technological applications of quantum physics in our country. We launched this particular mission because China has already taken a leap forward in quantum technology compared to all other countries of the world. And we are also trying to replicate the Chinese model of quantum technology development in our country. And for this reason, we have gone with what is known as National Mission on Quantum Technology and Application. All right, so rest in detail about NMQTA, we are going to cover in one of the current affairs class whenever this topic will float in news, and the current affairs class, that is the weekly Saturday 12 p.m. ritual that we are 12 noon ritual that we always carry on will take care of NMQTA there in one of the classes to come. With this, I'll close the session for today. I hope that I am able to deliver what is quantum technology. I hope I am able to deliver what are the applications of quantum technology. Do make notes of them. Do prepare proper notes because a question on these lines is expected. Signing off, this is Akash. Have a great day ahead. Take care. Bye.